Alright, let's get on to our review part 2. So today we're going to be doing our last 3 lessons. So inverse, piecewise, and arithmetics with functions. So we have a lot, and I'll be selecting maybe only odd numbers, or I'll do some of these for the arithmetics with functions, because they're rather easy. Okay, let's go ahead and get started with lesson 1.5. Question number 10. For each point on the function, state the corresponding point on the inverse function. Those the inverse relation. So this should be rather simple. Okay. This is not 0 degrees. Okay, let's move that. So question 10. Well, interesting text that we have here. So 1 and 2, so obviously we know what we do to an inverse relation. What happens is that we switch the x and y. So this should be really easy. So I'll just speed through these because it is really easy, and you guys should be able to just do it yourself and check with my answers. So -1, -9, so -9, -9, and -1. We're just simply switching the x and y. So 0, 7 becomes 7, 0, and then d will have, so now we have f of 5 equals to 7, so x is equal to 5 and y is to 7. So when we switch those around, it's 7, 5. And then e, when we have x equal to 0, y equals to -3, we'll have -3, 0. And for f, we'll have 1 and 10, so 10 and 1 should be our inverse. Let's go ahead and get on to question 11. Given the domain and range of a function, state the domain and range of the inverse function. So what we knew about the domain and inverse is that it will switch around. Because we switched our x and y variables, our domain and range interchanges as well. So for A, original is x is all real numbers, y is all real numbers such that -2 is less than y less than 2. So our inverse, we will have to switch these around. But instead of switching x and y, we still keep x and y, but we just switch these around. We switch this little additional requirement around. So x is all real numbers such that -2 is less than x less than 2. This is how it works. And now y is all real numbers. And then b, we'll have x is original. We have x is all real numbers. X is all real numbers such that x is greater or equal to 7. And then we will have y is all real numbers such that y is less than 12. Right, that's pretty simple. So after we switch it inverse, this additional requirement for y should become the additional requirement for x. So now x is all real numbers such that x is less than 12, and y is all real numbers such that y is greater or equal to 7. So these inverse functions are really, really simple. It's basically just switching the x and y around. And let's go ahead and get on to number 12. Graph each function and its inverse relation on the same set of axes. Determine whether inverse relation is a function. So we're only going to do this by just literally algebraically, because I don't want to graph it, and you guys should do that on your own. Graphing should be really easy. So when we know about a quadratic, this is obviously a quadratic, 12a right here. We have a quadratic function. And what we know about a quadratic function is that if we inverse it, it will have 2 branches. A top branch being the positive square root, and a bottom branch being the negative square root. And because we have these 2 branches, that means for every x value, there's going to be guaranteed 2 y values. So therefore, because the inverse function of a quadratic function does not pass the vertical line test, therefore the inverse is a relation. And now let's talk about 2 to the power of x. So that's an exponential function, right? So what is the inverse of an exponential function? So the original function is an exponential growth curve, and it passes through 0, 1, with a horizontal asymptote of y equals to 0. Its inverse will be reflected across y equals x, which will create a logarithmic curve that passes through 1, 0, that has a vertical asymptote of x equal to 0. Now, so our inverse is a logarithmic. How do you spell? Okay, logarithmic function, and because it is a function, therefore the inverse, the inverse of oh my god, therefore the inverse of an exponential function is a function. Okay, now we actually have to find the inverse of the function, so we have to do some actual math now instead of just explaining it to the teacher. Let's go ahead and do this. So 13. Right away we see this is a linear function, so that should be pretty simple. All we have to do is just switch x and y around. So let y equals to 2x plus 1, because we can't use f of x, right? We can't use f of x. So let's just switch the position of x and y. So instead of that, we'll have x equals to 2y plus 1. And now we isolate, so 2y equals to x minus 1, and y equals to 1 over 2x minus 1. Okay. And there we have that. So let's go ahead and get on to b, which is x cubed. Now x cubed does seem interesting. So let's go ahead and do that. So let y equals to x cubed, because we can't use g of x. So simply switching it around, x equals to y cubed. Now what are we going to do is that we're going to cube root this. So we have, a single y on the right side. So y is equal to, how do you write cube root? Okay, x to the power of 1 over 3. That's a cube root. And therefore, we found it. Let's go ahead and get onto this. Graph the following function, which I will not be doing that, but I will be determining if it is discontinuous or not. And I'll also be stating the domain and range, blah, 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 etc., etc. So let's go ahead and get started. 14. So the only place that these two functions can be discontinuous is at the connecting point. Because this is a linear function, that's also a linear function. And we know about, one thing we know about a linear function is that they always exist. They will never be discontinuous. They don't have any asymptotes, they don't have any jumps, they don't have any holes. They will always exist. So if these functions will always exist, the only points that they cannot exist is when they have the connection point. So let's check the connection point. So check boundary at 1. So we can use a limit, or we can just simply calculate the value. So 2x, so f of x equals to 2x, f of 1 is equal to 2, and then g of x is equal to x plus 1, and then g of 1 is equal to 1 plus 1, which is also 2. Okay, so the function is continuous at x equals to 1. Right, so that means the function, because this is the only possibility. Okay, because x equal to 1 is the only possible place where the function is discontinuous. Where the function is discontinuous. The only place where the function is discontinuous, but it is continuous at x equal to 1. This means the function is continuous everywhere else. Okay, domain. Let's get to the domain. So because this function is continuous everywhere else, this means x is all real numbers. Okay, so let's talk about the range. So we have two linear functions, and obviously we have this which is going to reach. So let's check in behavior. So as x approaches negative infinity, f of x approaches negative infinity. Okay, that's good. And as x approaches positive infinity, g of x, which is our second function, x equal to 1 here, g of x approaches infinity. This means that we'll have a range of y is all real numbers. And you do have to do this in behavior check to prove that, even on assessments. And I'm pretty sure most teachers require that as a step. because you can't just jump to conclusion. Okay, let's go ahead and write to 15. So there's a little bit of overlap here because the copy and paste wasn't so well. So, wow. Write the algebraic representation for the following piecewise function using function notation. So we have this. So right away after looking at this is definitely two linear functions, without a doubt. So let's talk about the slope. Obviously, the only thing interesting to talk about when we talk about linear function is that they have different slopes, and obviously they're discontinuous. This is a huge jump discontinuity here. So let's see. So we have a left down arrow, and it's at 2, 5. And 2, 5, it has a slope of negative 3. Right? Because when you see here, from 1 to 2, there's 1, 2, 3, negative 3 jump. So leftward has a slope of negative 3. And when we describe a linear function, we use two things, the slope and the y-intercept. So we can see the y-intercept is at negative 1. So our left one is y equal to negative 3x minus 1. And let's talk about this one on the right. So this obviously this has a positive slope of 3. I was looking the wrong way. Yeah. So on the rightward has a slope of negative. So let's see. This is definitely a negative 1. Oh, their x-axis is a little stretched. So rightward has a slope of negative 1. And a y-intercept, if we keep on dragging it here, it will just be simply 0. Y-int of 0. So this one will have a function of y equals to negative x. Because their x-axis is a little stretched, it will be kind of hard for you to tell. Anyways, so this is the function. And then for this, since this is a solid dot right here on the top, it will be for x less or equal to 2. And since this is a open dot here for x greater than 2. And let's go ahead and let's just, this is perfect. This is all we need. You can go ahead and write it into function notation if you want, but I'm not going to do that because I am just typing it out. Okay, 16. If f of x is equal to x squared plus 1, as x if x is less than 1, or 3x if x is greater or equal to 1, is f of x continuous at 1? So what we have to do is simply check these two. So we have to check. So let f of x equal to x squared plus 1. And f of 1 will equal to 1 plus 1, which is 2. Let g of x equal to 3x, and g of 1 is equal to 3. Because there is a jump, because f of 1 does not equal to g of 1, therefore, we can conclude that there is a jump discontinuity and f of x is not continuous at x equal to 1. Okay, let's move on to number 17. I'll also enlarge this, so if you guys need, you can take a picture of this. Just enlarge that a little bit. Okay, hopefully that's big enough. 17. A telephone company charges $30 a month and gives the customer 200 free call minutes. After the 200 minutes, the company charges $0.03 a minute. Write the function using function notation. Find the cost of talking 350 minutes in a month. Find the cost of talking 180 minutes in a month. Let's go ahead and do that. So first let's talk about, this is obviously a piecewise function problem. So where's my text box? Why is my text box not working? Copy, paste. And let's just, wow. Okay, there we go. Wow, we have very big text. So let's define the two functions that we need. So let's see. Let C be the cost of call, while M be the amount of minute of call time. And then so C of M will equal to 30 if m less than 200. If well, we kind of gotta bound it on the lower end as well. So if 0 is less or equal to m is less or equal to 200, and c of m is equal to 30 plus 0.03 m minus 200 if m greater than 200. Okay, so this kind of makes sense. So let's explain it. So it's going to be constant cost of only 30 bucks if, you know, only 30 bucks if, our code time is within the range of 0 and 200 minutes. And as our m gets above 200, we want to add $30 and m minus 200. So every minute above 200, we will have to calculate it. We'll have to calculate it using 3 cents per minute. Let's go ahead and move on to B. Find the cost for costing 300 minutes in a month. So obviously 350 minutes, it qualified immediately for the second bracket because m is greater than 200. Let's go ahead and calculate that. So we're just plugging it in. So C of 350 is going to equal to 30 plus 0.03 plus 350 minus 200. That's 150. So what will this get us? So this will immediately get us 30 plus 3 cents times 150, so 450. So now that would be equal to 34.5 cents. This is in dollars. Keep your values. So for C, and we see cost of talking 180 minutes a month. So because it qualifies for the first bracket, so C of 180 is simply equal to $30. Okay, let's move on to question 18. So this is less than 1.7 as well. So f of x is equal to all of these things, and g of x is equal to all of that thing. So we gotta add it together. So as we talked about on a very last second, so 0, 6, 1, 3, 4, 7, 5, 8, negative 1, 2, 1, 4, 2, 3, 4, 8, 8, 9. What we simply got to do is find the common domain elements, because on the last lesson we talked about to do any of these arithmetics with functions, they must have similar domain. I can't add two functions that doesn't even have the same domain. How can I add them, right? So let's find the similar domain. For which x values does both f of x and g of x exist? So f and g both exist at x equal to 1 and whatever is there. Oh, x equal to 4 and 4, right? So all we got to do when we add them up is simply just add it. Add the x value, add the y values up, right? So add x equal to 1. Add x equals to 1. What are we going to do? Add x equal to 1. We're going to go ahead and just add the corresponding y values. So 3 and 4. So let's add that. 3 plus 4 equals 7. Okay, perfect. So, and add x equal to 4. We're going to simply add those two. So 7 plus 8. So 7 plus 8 is equal to 15. So now we'll have 1, 7 and 4, 15. We added the functions. That's really simple, right? Now, since we found out where f and g both exist, we can just use the same thing for b because we're minusing them now. So at x equal to 1, we'll have 3 minus 4, 3 minus 4, so negative 1. And then at x equal to 4, we'll have 7 minus 8, which is also equal to negative 1. So we will have 1, negative 1, and 4, negative 1. Now let's move on to question number C. So C, we're not multiplying them. It's not any harder. It's just different. Right? So at x equal to 1, we'll have 3 multiplied by 4. So 3 times 4, and that's going to give us 12. And at x equals to 4, we will have 7 times 8 equal to 56. So now we will have 1 and 12 and 4 and 56. I hope I did my math right, and I hope you understood it. Let's go ahead and get on to this. F of x is equal to 2x squared minus 2x, and it's defined across this domain. And then we'll have another g of x, and it's equal to here. So we can graph the following. So you guys can graph this. So this is all you guys. I will not be doing this question because I'm not trying to graph it. I won't be graphing it. It should be very simple. So I'll give you some clear instructions. So g of x should be really easy. That's a linear function. This, you just have to factor it out, find some key points, and you're all good. And obviously, we can see that there is a slight bit of overlap of domain. So the entire f of x should be the only domain that we're able to add or do anything. Because our f of x is from negative 2 to 3, while this is from negative 3 to 5. So the domain of g of x completely sucks up the entire f of x, right? F of x is defined everywhere where g of x is defined. But g of x is defined everywhere where f of x is defined, but it's not vice versa. So we can only add and multiply it within this domain. So I hope you guys be careful on that. And let's get on to this. So we just have to do some matching. Let's go ahead and I love matching questions. These are so fun. So let's go ahead. Wow, why is it so big? Let me just smaller this a little bit. Smaller. Let's go over here. Okay. Number 20 is that we're gonna match some arithmetics with some operations. Let's see what they've done here. So f of x is equal to x squared plus 2x, while g of x is just x plus 1. So let's go ahead and see what they can do. So A, how does this happen? So we have x cubed now. So x cubed, that immediately remembers us that, hey, wait a minute, it's x cubed, right? So if it's x cubed, that means they gotta be multiplied together. Or how can we do this, right? If they're not multiplied together, there's no way that we're gonna have a cubic function. You can add, you can do anything, but you won't have a cubic function. So A is matched to D. And let's check that a little bit. Let's check it arithmetically with our mind. So x squared plus 2x multiplied by x plus 1. So that will give you x cubed plus 2x squared plus 1x squared plus 2x. So that will have x cubed plus 3x squared plus 2x. Okay, that makes sense. Perfect. Let's get on to D. So we immediately would notice, oh, whoa, there's a negative sign. What's going on here? Right? If there is a negative sign, that means one of them is minusing the other, for sure. But how can we have two negatives? So that means if our main coefficient, if the leading coefficient of x cubed, x squared, that's negative, then that means then f of x was the one getting subtracted. So g of x minus f of x makes sense here, right? Let's think about it. So g of x minus f of x, so it will be x plus 1 minus x cubed, minus x squared minus 2x. So that would leave us with negative x squared, and then x minus 2x, so negative x and plus 1. Okay, that makes sense. So B is matched to C, so g of x minus f of x. Now we can see here, x squared plus 3x plus 1. Right away, we can see that 2x plus x added up together. So that means they're added together. So C is matched to A. And then finally, D is obviously matched to B, because what else can we do here? So this is a little bit. Let's go ahead and do the last question here. This is our very last question. This should be the end of your practice, and hopefully you're ready for your Unit 1 chapter test. Let's go ahead and do this. So f of x equals to x cubed plus 2x squared, and we have g of x equals to negative x plus 6. So we have to complete this table, which you can go ahead and complete. And then you can graph this and do this. So what I will be doing is just simply getting the equation for you. So this table should be really, really, really simple, because you have everything that you need. You have the two functions and you have the x value that you have to plug in here. So I'll do some for you. So negative 3, that's just negative 27 plus 18, so negative 9, right? Should be pretty simple. So 9 here, and then just fill it in. Anyways, I will be getting you guys the equation of f plus g. So the equation right here will have let's just do this. 20. Wow, I didn't mean to delete that. So 21c f plus g, sorry, f plus g of x. That's a new notation that we haven't learned before. Let's go ahead and do that. So that should, let's just plug it in, put whatever we have. So plus x cubed plus 2x squared. Now we add g of x, negative x, plus 6, and then we're doing this O of x. So which you don't have to write here technically, because you already plugged everything in. So let's just add it up. So we will have x cubed plus 2x squared minus x plus 6, and this is the entirety of it, right? And then you can verify this with whatever table. So technically the easiest one should be just 0. So let's see. So let's just verify with 0. So verify with x equal to 0 using the ordered pairs. So using our ordered pairs, so at f of 0, that should be just pretty much straightforward. So x cubed, that's 0 cubed is 0. 2x squared, 0 squared is also 0. So we have 0. And then g of 0, we will have negative 0 plus 6. So that's 6. Okay, that makes sense. Checking our. Sorry guys, the internet wasn't too good, and plugged out. Recording time is a little too long, so function. So f plus g of 0 is equal to 0 cubed, which is 0, 0 squared, which is 0, minus 0, which is also 0, so we will have just 6. Function is checked with ordered pair. And therefore, we are done. Hopefully, you guys graph this as well, and you graph everything here. And that is it for our practice. I wish you guys good luck on your unit test, and I hope you guys get what you want.